Okay, hi everyone. I'm Akshay,
My name is Earth.
My name is Niveditha.
and we're Team CompactCity from Studio Bhooshan. So the studio aims to develop research to address the need for rapidly buildable and yet engaging, well-constructed architectural spaces and urbanism. The two thrusts of research are building systems and urban AI. This brings us to our thesis question: can urban sprawl be efficient? Our thesis aims to address the challenges of urban sprawl by proposing a city growth model that can steer the urban form and sprawl growth. We view this phenomena of sprawl as a design opportunity through its deliberate creation and its subsequent densification.
Our definition of sprawl is a single function lowland efficiency settlement. As newer and rapid forms of transportation became viable, people travel further away from the city center to find open residential settlements that are low density developed at the expense of long journeys to and from work. But sprawl presents an opportunity when it creates parcels of low land value which lead to affordable living with quality open space outside city at negotiable distance from place of work, where we are looking to exploit this opportunity to control and design the pattern of sprawl. We look at a few cities like Atlanta and Barcelona. In our present tense, we see area of predominant character in concentration, mainly live, work, visit. For us, Atlanta represents a sparse density, heterogenic growth, and Barcelona represents a dense, homogeneous growth. In Atlanta, by identifying the transport nodes in the city, we learned that the public transportation system is serving a small region which happens to be the higher density regions. Public infrastructure cannot efficiently function in areas of low density. Then we look at our next president, Barcelona. In Barcelona, we learned that the public infrastructure is easily accessible to a significant population owing to its dense population. While Barcelona's compact urban form successfully achieves higher density compared to Atlanta, it tends to lack differentiation in character that could define distinct city functions, such as living, working, or visiting. This leads to an isotropic urban landscape where districts appear homogeneous.
The primary motivation is to develop an urban form that is both experiential and economically viable using automated urbanism and building systems. We look at literature precedents like Order Without Design on occupying and connecting to develop our urban systems, while Freyotter's thinking by modeling has influenced our building systems. Learning from Alan Berto's idea of looking at cities as labor markets, conventionally cities grow around labor markets, and as it grows, it transitions into urban sprawl around the city center. Our proposed growth informs the strategic location of district centers, which develops in proximity to one another. We look at the sequence of expansion and compaction by varying the number of nodes and distance from city center. This generates city parcels of different sizes based on these expansions and its subsequent compactions. We evaluate these iterations based on parcel size and proximity to city center.
Once we iterate through our sequence of growth and compaction, we use city builder games such as City Skylines to simulate and evaluate our proposed city growth. This allows us to evaluate through economic constraints like land value, customer value, and workplace value. We simulate our models of growth for a monocentric model and a polycentric model derived from our custom script. We evaluate this against a prototypical sprawl model. From this, we evaluate the distance to workplace, which informs potential job locations. We observe the distance between work clusters and people situated in sprawl zone. The monocentric model shows an increase travel to work time as the city grows. The land value evaluation shows that monocentric models generate greater regions of low land value when compared to polycentric models of growth. City centers showed higher customer values, which implies high concentration of commercial activities. Higher concentration of commercial activities directly affects economy of each model. Once we iterate through our sequence of growth and compaction, we learned that while City Skyline works on an economic model for function allocation, working on a feedback loop, where each plays against the next turn. However, it does not respond to phasing and densification once a city is created.
So our strategy is to look at these functions as districts and urban compaction as a means to achieve this control sprawl. We split our thesis into two parts. Compaction of district and densification of sprawl. We look to achieve this compaction through control densification of districts, its distributions, and the connectivity between them. This relates back to our building systems and fabrication strategies. And the urban architectural intelligence comes from the logic of distributions of district centers. To summarize our workflow for our automated urbanisms, we pick, this one. Why is not? We pick city nodes based on existing land value. We build the load network connecting existing infrastructure, which then guides our parcel generation and expansions. We use participatory land use allocation to guide our city growth phasing. Each function responds to specific shape grammar rule sets. Once the urban fabric is generated, it is then translated into tectonic interpretation with our form-finding explorations. To implement our theory of compaction, we choose to implement it between Walthamstow, Leytonstone, and Stratford. The existing function is in the site exhibits a combination of live and work zones. The site is contextually rich in natural features which affects the function organization. We are also looking at major access points in our area to study an existing transit points as our initial input. So the vector fields are informed by the external site influences. This helps us to merge our internal input conditions with our contextual response. And here we tested with varying the number of city nodes input at different locations, and we evaluated in basis on size of parcel generated. The smaller parcels are generated in the city, and as the distance increases, bigger parcels are generated in the sprawl. The existing size context informs the generation of road network. This information overlaid with our vector field is our input condition to generate parcel and their building wireframes.
With our generated parcels with vector information, we use participatory zoning and land use allocation to establish the city's growth phase and function distribution. We play the game at global level and local level. The global play is a top-down approach that essentially dictates the phasing of the city's growth, from sprawl to densified sprawl and eventually to city by assigning city location. The local player is a participatory bottom-up approach that dictates the function distribution in the city. In the initial field, we generate a field of sprawl which responds to the road network. This then triggers the generation of open spaces which are influenced by the site's external natural features. The contextual response informs the land value, which in turn influences the city node allocation. The player spends city sprawl tokens to generate city which in turn triggers the next phase of city sprawl growth. This again updates the land value trigger. This again updates the land value, which triggers the next phase of growth. So the growth logic for our city is informed by this phasing feedback loop. We look at the game as a method of generating an economic and phasing model for the city growth and densification in sprawl. The game ends when the city has achieved its mean average target revenue. We played the game to iterate through different growth strategies. We evaluated the growth sequence based on revenue spent and time taken for each growth phase. We see that the 3 nodes growing simultaneously densified with more revenue generated and comparatively lesser amount of time to achieve the target revenue. From the global play, we get each growth phase, and the local player takes turn by turn to allocate functions for each parcel. The local players are live, work, and visit. The players pick the parcels based on distance to the city center, and the rate of revenue return is calculated based on the scoring matrix. The scoring matrix follows the rules for proximity for each function. It is more economically viable for the live player to build away from the city while the work player tries to build closer to the city center. Closer to the city center. This is a reflection of our notion of labor markets and labor supply and affordable living closer to the city. Once live and work player populates the city sprawl, visit assigns itself closer to the open spaces. The visit populates itself in an 800-meter walking radius from the open space. The players play till they populate all the city sprawl. This triggers the phasing feedback loop. We iterate through the game based on different ratios of live, work, visit to evaluate different function distribution. We evaluate them based on function scores and distribution ratio. We also tried varying the percentage of green coverage to achieve higher scores for each function. This is the summary of our game at each phase of growth and its subsequent function allocation. We see how each growth phase triggers the land value and subsequent densification of sprawl.
We then move on to the local rules for primitive generation. The shape grammar responds to function of the building and its context by varying depth and orientation towards city center. We set the primitives for our building to respond to phase construction. Depending on the function allocation in every phase, the primitive generates podiums of said functions. These podiums respond to its immediate context based on its function differently in the next phases. Live functions cluster closer to the road to generate semi-private open spaces between them, whereas work functions move away from the road to generate public plazas. When the city sprawl densifies, the podiums add towers on top to respond to their densification. The podiums in visit behave differently based on their proximity function. If it's closer to a work function, the tower generates away from the road. If it's closer to a live function, the tower generates next to the road. When the parcel sizes grow, the massing splits orienting in the direction of city center. Parcels of the interior respond to their context differently, again based on their function allocation.
The simulation shows the 3D program distribution where function plays turn by turn at every growth phase of city generation. And here is the one phase turn. Yeah. Then function add podium at every city sprawl phase, and when they densify to become city center, towers are generated. And we use the participatory allocation of city facing and function mapping to inform the height at each phase of growth. The max height is determined by the relationship between parcel area to land value. This gives us the max height the parcel can grow to in that phase. And then we use figure and graph mapping to evaluate the gradient density and porosity of this urban fabric. And this is our urban fabric at its final state of densification and growth, showing the hierarchy of open spaces like parks, roof gardens, and plazas. And high gradient from sprawl to city through city sprawl. To summarize, growth logic for our city is informed by a phasing feedback loop. The contextual response triggers the initial state of growth followed by subsequent densification. Our thesis aims to densify the sprawl through improving the connectivity across the city and sprawl. And at the district level, we establish a primary connectivity at different growth phases from city to sprawl through visit functions. When three leaf parcels cluster together, they form a podium which connects to the city through a visit function. So for our thesis, connectivity plays an important role because it helps to us achieve this compaction through densification of districts, its distribution, and the connectivity between them.
So we move on to, we discussed, connectivity plays an important role for our thesis. So we looked at different levels of connection. As a starting point, we used form finding methods to understand compressive surfaces. This is our initial attempt at casting and inverting our form found to create a compressive shell structure. We try to digitally approximate our form found structure to understand different topologies, control parameters. We found that rather than a point interface, a hard edge interface was more controlled. The hard edge interface can be concave and convex. This also allows us to iterate with combinations of these. We also found that immediate touchdown points give more span control. We attempted to explore a multi-level connectivity, same level connectivity, and nested shells and different load and asymmetrical points of interface with compression-only form. We started studying multi-level connectivity across with tensile shell structures. We physically modeled to find this connection between buildings. We studied how they would interface with different building edge conditions. This is our initial form found approximation and its stereotomy. We tried to interpret connectivity as a skeleton structure. We explored with varying curve network topologies by hanging chains. We tried to approximate a hanging model to stick networks, which still carries forward information about the hanging chain. We explored catenary topology network at building level. We introduce control by exploring with various levels of subdivision, points of touchdown, and adding connections between them. We studied the node geometry in our stick model and tried to translate this joinery as conic intersections. This allowed us to approximate our stick model to developable surfaces. We tried to digitally develop this, and with our first study, we understood as the node angle approaches 180, it tends towards parallel, and as the node angle tends towards 0, the outer rail will kink, and at a point, the inner rail will deviate from the outer curve. This is our form work for our concrete casting, and this is our us trying to develop our form work with our form work. We use developable surfaces to create formwork and generate offsets to manage weights. This is our casted concrete node iteration.
Our thesis requires our fabrication to enable us to look at phase construction as well. So we started looking to merge our two systems as a phase fabrication. So we explored physically how these systems could merge with one another. And this was us trying our first iteration with this phased construction system. Then we started to study our model digitally and generate details of interface between surface and stick. This is our initial attempt to approximate our shell skeleton system, which responds to our automated urbanism.
So from this digital approximation, we studied the interfacing between our stick and surface fabrication techniques. This is our node fabrication study from digital approximation. We try to study them as individual developable node iterations. Then we use our building systems to translate our program mix and shape grammar to tectonic interpretation. So this is the podium phase. And this is the interpretation respond to our urban growth system and phases construction.
Here we look at a few scenarios of how we interpret our program mix at city level with our building systems. This is one scenario. This is another scenario where we have a visit and a live above it. And this is our architectural building system interpretation. In another scenario, we're looking at the same interpretation, but a different architecture system because of the contextual condition. In this condition, we're looking at a visit at the bottom and a work above this. And this is our translation through our architecture system, through the shell structure and a skeleton structure, lightweight skeleton structure above. In another scenario, we're looking at a similar condition with a shell condition at the bottom and a lightweight skeleton structure above. We also try to look at how our interior spaces would turn out. And here are a few scenarios of our internal spaces. Here we look at how the overall district would look with our architecture building system. And here are a few scenarios of this. And here we have a short walkthrough through our city section. This video shows us going from the urban sprawl to the city center. On that note, we'd like to end our presentation, and we'd like to thank our studio master, Shajay, our studio assistants, Henry and Jayanaveenaa, and our Phase 1 helpers, Palash and Raj. Thank you. We'd also like to explain our models. So initially we began with our form finding exercise where we looked at two versions of our models, where we looked at a surface version and we also looked at a skeleton version of the same. From here, we started looking at how we could look at the catenary explorations and see surface interpretations where we studied multi-level connectivity of the same. In this model, we looked at how we could study a nested connection, a shell within another shell. On the next stage, we try, as we mentioned before, we looked at how we have a shell at the bottom, and as part of our phase construction, we have a lightweight skeleton structure happening above this. And this was one of our architectural interpretations of how this physical model would turn out. Here, we also looked at tensile shells as bridging elements between buildings. And this model, here we studied how we had different interfaces, one from a flat surface and this ending into the floor slab of another building. Here, we looked at how stereotomy could be used as a potential fabrication method for these tensile shell structures. And these are a few examples of our conic section nodes that would be used in our buildings, possibly. Yes. Thank you.
Mike knows you.
Slightly embarrassing. Well, I think there are lots of problems here, I have to say, especially as you cycle through and the differences between tension structures and compression structures become very evident. If you compare these two models here, you can understand how that works, or it couldn't possibly operate itself unless it's welded chains or frozen chains. The one on the right breaks all structural engineers' basic rules of compression structures, because you don't have triangular systems, you have quadrilateral systems and triangles mixed. If you have a quadrilateral system, it's not stable, which means that parts of this aren't necessarily all tied together. You need triangles in order to give rigidity. The moment things aren't triangular, some force is going to go off in an odd direction, as it does here. And you'll find that there are all sorts of funny things happening. If you imagine the loads happening on this structure, especially whether I see it as a generic friendly illustration or whether it's meant to be a structural model. It's probably not meant to be a structural model, so I'm being a bit naughty. But nevertheless, you have to have it based on triangles if it's a compression structure. Otherwise, the joints suddenly go like this. And there are several places in that model where they will do that. So there's a fundamental member or two missing. Whereas in this works perfectly. Mother Nature decides exactly how it works. It's very elegant. It self-resolves all its internal forces. The moment you turn it upside down, things that will hang naturally in this way will completely displace. That will never exist in a compression model. So therefore you have to adapt the structure. So the genius of that, what you have to do if you're going to design throws at buildings, is to understand the basic rules there and then do the opposite in a compression structure. So there's some cautions there. I'm sure you don't have a structural engineer on hand to beat you around the head, so I'm sure you're safe. But nevertheless, it's an exploration, but it also shows a few issues which are not well understood, I think, there. I thought the urban issues were interesting. It's a little bit formulaic, but I've treated it as the game that you described it as a beginning, so doesn't want to be too judgmental about it. And it seems to me that you've hopped from 2 dimensions to 3 dimensions well, and you've illustrated it well, but I'm trying to see a link between it all the elements, the full story, if there is a full story. But nevertheless, there's an awful lot of work here.
Wow, actually it seems pretty strong, but I just interim want to challenge Mike a little bit. I mean, you clearly this is a coherent catenary frozen up, and it's true, maybe you should have used it somewhere. Here you have this kind of, some of this kind of compression shells up to this point, and then what you plug onto that is some kind of skeleton structure which is partially triangulated and then partially using moment connections. And I think something like this could work, and the idea we pushing forward is that your phase change and system change as you go up the tower, so you have you lose out some of this triangulation and it becomes more frame-like, and then the core takes over most of the stability, etc. So we're thinking about these skeletons not as uniform systems, but as systems which change according to the load which all accumulates downwards, both horizontal and vertical. The particulars I can't necessarily defend, right? But that there is something where you have degrees of triangulation, and then you go into Verendale, and then you go into frameworks, etc. I just think it's meant to be a structural model. It's meant to have structural rationality, and I think it does have that to some extent in the overall. But I feel also that somehow this has this kind of tripartite. In the final models, you only have two parts. You don't have oftentimes the three parts. But what I find striking is the productivity of using this kind of parametric module proliferation and variation adaptation, how you can make a city feel coherent when varied. Maybe it's as on the side of monotony, should be more variety maybe, and you have three systems, maybe there should be more. This should have come in, so you have, I think it starts to work. It's definitely not a kind of garbage spill or visual chaos. It has some order, and you're aligning functions with tectonics, residential, office spaces, podium, retail spaces, etc. So I think it works. It gives me confidence. It's a nice kind of sketch, really. And on the tectonic translation. On the urbanism itself, I also feel has some merit, but the gaming, although it's quite elaborate, it's always hard for us to follow exactly how you see the process, how you see the economics playing out. That you're trying this, I very much subscribe to, but it would require us a seminar to sit down together to appreciate whether there is kind of flaws like Mike sees here. I probably see quite a few flaws in your economics.
But if you think of it as a gossamer external lightweight net, then you can make it work. But you're doing half and half here.
That's what that's what I like. That's what I like.
Schizophrenic, but
exactly.
In which case,
we want the whole point. I think the aspect of what we're driving is the system differentiation and phase change within a single structure, and not a uniform system.
Here, all of this is rational.
Yeah. Okay.
Here it goes weird.
Okay.
And then
Okay.
it becomes rational at the bottom, and there's opportunity for great discussion.
Maybe I need another few years of.
Exciting things on the planet.
I need to hone my intuitions for another few years to reach the same.
I do like your joints. The model joints is always a satisfactory exercise. If you understand roads, directions, form, and they all interact beautifully.
I also want to say congratulations. I mean, you really managed to bring it down to the eye level, which is very exciting. I think it looks really stunning. It's very ambitious. I'm not sure if you can apply it to the whole master plan. And then to the master plan, I'm wondering, I mean, you basically, why was the decision to erase the whole area or not keep some areas? It's just like you cut out and erase the whole. Was that ambition just to not work with the context?
So here we're just looking at a sprawl densification system and using the site as a prototypical area to test out our system.
Right. Okay. I mean, I appreciate that you guys you see that there's some connections, there's smaller houses which connect to the surrounding. There's some ambition to really make it more integrated. I saw in terms of the streets, sometimes they align, but sometimes not just yet. But I appreciate the idea just to test it out on the site. So well done.
What is interesting for me is the methodological process, even if we have some gap between urban studies and form finding. But I think it is difficult for your ages because you always have some kind of double situation. You always have parallel reality. Even in urban studies, you try something and you find the other things. Like in the form finding, you have totally opposite methodology and techniques to find something very specific. But what is interesting, just aesthetically speaking, at the end, I find some very specific tectonic poetic in your images. Even it is not matter it is correct or not, you have time to find all elements in parametric and construction, triangle, etc. But you're trying to find some kind of architectural language in all that process, which is really, really difficult. Thank you.
Yes, excuse me. I completely agree. I think the best part for me of this project is to hear at the beginning your statement that the commerce is your driver, and then coming at the end of the projects to see how your structure actually lands on the ground and how those beautiful spaces could be created for really commerce, for connection. It's very gracious the way in which your building is landing, and it forms itself to some spaces for common use that are actually quite successful, I think. So beautiful projects, really, from the inception for your statement all the way down to your execution. Thank you.
Yeah, I cannot add almost anything. Just again back to the gamification, because I really, maybe that's more to Shajay actually, but I think it's really an interesting way of approaching this. Really, really interesting. And here again, I think that the work would get so much stronger when actual data was actually involved. Because here, for example, you were talking about the monocentric city or the polycentric city, and I was wondering, how do you decide? How do you go about what is best and what is not? You know, on what basis? What are the scenarios that you are playing out? And I think if you were to look into reality more using the data of the reality, let's say, I think you would have some answers that are not purely from a design perspective, but they are driven by other forces that are for real. So I think it would be incredibly interesting to go like this, if I may say. That's all I can say.
Shajay's always worried, like damage control. He wants the last word.
I can say the least.
No, I'm teasing. I think to Marta's point with the gamification, and even to some of the things that Mike was saying, I think if you think about the game itself, it doesn't exclude the fact that it should have this embedded digital form finding embedded within it. So I think instead of this becoming just a planning tool, and I don't mean just because it's a very complex issue, but the way to problematize it is to already embed it with the logic of structuring, you know, in this case, the catenaries, the Gaudi-esque, Frey-Otto-esque, you know, not one-to-one translation of one material system, but different programs potentially interpreting those same models differently. You know, the difference between Gaudi and Frey-Otto, for example, or the difference between lightweight structures for some of the programs versus this kind of more shell-based, you know, concrete, steel, wood hybrids that you're working on. I feel like if you do that and you let the catenaries do the work for you, then you will find more novel ways to spatialize your city. Because in some ways, you know, the difference between a polymodeling frame and these very peculiar ways that you guys are doing the shells, because you always put these screws in them, which give you this like strange, very analog vector field on top of it, you know, which is kind of interesting in its own right, because I think it gives you some kind of information. This model is a bit messy, it's a bit weird, but it's novel. And I think there are some interpretations that you could utilize. There are definitely parts, I agree with Mike, that are not working at all. Gaudi would never, Gaudi's tower. It's not a crime. I just think like the issue of looking at it is to set up the rules so that you have like acts of discovery. You may not be conscious of it, but at least if you bet it into the game, you know that those rules are somehow underpinning something that you can reverse engineer because you're using generative methodologies to instantiate that in the first place. And then the radial, the linear, the more hybrid seeded versions of the stuff that you're doing doesn't have to be run all at one scale. You could recursively subdivide. You can start to think about spaces nested within other spaces so that you could have different ways of interpreting, these large shells on the ground are going to have, a very different kind of space occupancy than some of these smaller, almost like archways that are maybe more familiar. So I think these are the kind of opportunities that you guys need to look at. I do think the gamified space is very important, but I feel like the generative computational logic is somehow never included in that. And I would suggest, as the studio is progressing with this work, that it's really coupled and you make no distinction. So you see the generation, even the wireframing of that, as part of the outcome. So you don't have this literal planning tool versus then, now I have to translate what these very generic volumes actually are. Because then I think you'll be able to actually work through the different details. And I do think that you guys should spend more time on this generative work. I feel like it's, one or two models. The third or fourth model, I think, would have said something different, even with the same techniques. So I feel like that came very early. And then the question was, what's the right way of interpreting it, instead of trying to let the digital tools kind of version that for you. So you don't have to make all the effort all the time to do these things, but you get the digital analog, feedback, which I think is where we want to make computation more intuitive. So we build a sensibility so that even if it's not fully engineered, we at least understand the basic principles and the logic behind that. And I think you're in a good position to be self-critical of the work when you see it all together. I think you see a process, something that you went through, and I think, of course, it's not all coherent, but it's part of a family. And I think you can start to take stock of the things that were more successful and at least start to come to terms with how you would, take it further, not just to design an envelope for this tower or something, but really like evaluate the criteria that you have to make those evaluations, as Martha's point was kind of outlined in terms of a planning. So I think you guys have learned a lot from this process. I just think it's important that you become authors and your own critics so that you build that self-criticality within your process, and you don't have to go through this whole linear process to then start to explore more non-linear methodologies. Let the computation kind of drive some of that conceptually, I think, would be, I guess, the things that I would encourage Shajay and the team to kind of consider a little bit more. And program is not everything. I think intervene with maybe more cultural aspects of how you see the city and living, because you guys present it as a technical object. And then the criteria of evaluation is always on the technical, and it should be when you present it this way. But I think how you think of this thing as a living environment, as a city, how it's evolving, what's adaptive, how can it be reused in different ways, I think that's also part of the gaming logic, which we talked about in the first team, and I think it is something that you guys should consider as well. How does this really deal with change and uncertainty? Because that's a very big part of these larger developments. And the more that you guys can allow people to participate, I think the better you'll be to be able to serve their needs, identify different communities, stakeholders, all of the language that you guys are using in the studio, but to do that in a much more impactful way, I think. Shajay. Or young.
Maybe not closing, but I really appreciate the amount of work that you have done, and that you went from the really bird's eye view down to the eye level, and I think that in itself is a massive accomplishment and super. And I really like where you end up, the spatial quality of the renders on eye level. I think is a one thing that while you were showing there's a moment in the early stages where you actually having some of these simulations have a 3-point intersection, but then you end up with everything is 4-point intersection, the road network, and I think the same creativity that you express on that level here, would also be worth exploring on a layout master plan level. Right? There's a massive difference if you would do the same where everything is in a cellular grid with a 3-point intersection. And look at real data and see what it means in spatial terms. I think would be worth exploring in the next stage. Did you?
Yeah, I think I would tend to evaluate like all projects on the basis of how much I learned working with you, and I think it's been very rewarding, like trying to synthesize like various prolific experimentation, and I think that's something that you should take a lot of pride in, because the models are talking for themselves, because you do invest a lot of effort into making them, and maybe you don't utilize all the information subsequently. But I think a few things that I would like to point out that I learned working or aiming to synthesize work that you are producing, and one of them was like why as architects we should like do any amount of urban planning, or why we should do why we should have like these 3-part things like urban planning, urban design, architectural design, like in the context of needing a lot of new cities, right? And traditionally like there's urban planning and then some like does the urban design. All of this takes too long, and we don't have like that. So we need to deliver like architectural vision alongside like some of the economic aspects and definitely the urban aspects of which some of the things that I wish you had done a lot more was to look again, like the first team, more at the achievements of parametric urbanism, right? That and like how we could build on that, like because like a project cannot innovate at every level. So we can already stand on the shoulders of what has been achieved, and some of it is coming through, like you're picking up the language of vector fields, like the scalar gradients. I love the fact that you're starting to look at like shape grammar, which is also something that like people like George Steiny already explored like a long time ago. Like, but we can bring it into the kind of functional use in the 21st century, like where we have to build a lot of these cities. But I agree very much with Theo that like what is also missing is a compelling vision of like what life in this city would be like, right? Like, and I think towards the end you get there. Like as Patrick was saying, there's we can see that there is beginnings to be promise of something, that it doesn't result in some kind of arbitrary urbanism, but there's some coherence, and also like this structural system, like just to pick up on that, which you didn't emphasize enough. I think that there is a compressive load-bearing podium onto which you can have these lightweight skeletal frame structures, like where you can have like vary the number of floors, like which is what a gamified urbanism might expect. Like sometimes you need like a 30 stories, sometimes you might need 50 stories, but that I think conceptually you haven't assimilated that like fully. That the steel construction or timber construction, which we're showing in some of the renders, also adds that additional layer of information and coherence to the urban fabric. Like, and so overall, I think like it's been like very rewarding working with you, and I think you should take a lot of pride and definitely not see this as the end of anything. Like it is the beginning of a lot of things you could explore further in your careers, because like where there is urbanization, there is a rapid urbanization, there are all these opportunities for integrating multiple scales of study. Like, and I think you have shown the capacity to integrate, and I would strongly encourage you to dedicate more time as your career progresses. So well done.